The purpose of this little preamp kit is to decide categorically whether adding tone controls to an otherwise excellent chip colours the sound and messes up the performance of it. This makes use of the 5532, two of them in fact, and it has bass and treble and mid volume controls. Now admittedly, these potentiometers are not the world's best potentiometer, but saying that, I've used them before and I found them pretty good considering the price of them. One of the issues will be, are these pots linear pots or logarithmic pots? Because definitely the volume control should be a logarithmic law, and the other three should be a linear law. As there's no tone defeat on this board, you're relying on the fact that when the potentiometer is in the center of travel, it should neither boost the frequencies nor cut them. Now obviously if they've supplied logarithmic pots, that's not going to work. They must be linear pots. Now I've already had a quick look at these, and there's good news and there's bad news. The good news is they're all linear pots, but that means the volume control is also a linear pot, and the effect will be, if that's off, it will get very loud very quickly, and then when you go further up the scale it won't get much louder, because the idea of a logarithmic pot is that it mimics sound levels detected by your ear. People always think that on an amplifier that is maximum power, but of course this is purely a tap. It has no correlation between actual sound levels at all. For example, say your amplifier has a sensitivity of 1 volt on the input. That means if you turn the knob all the way round, 1 volt going in will drive the amplifier to maximum power. Now, if you put it halfway through its rotation, because it should be a logarithmic pot, that will not be half volume. And another thing that confuses people, they think that as that's maximum power, there won't be any distortion. But think again about your 1 volt amplifier, so input sensitivity we're talking about. If you put 2 volts in, when you go to there, 2 volts are going into the amplifier, which clearly will grossly overload it. So maximum power on that basis might be there, or there. I mean, it's not. It's quite hard to demonstrate this with a logarithmic pot, which is what it should be. So this is what I suggest you do. Here is your potentiometer, and I'm putting this knob here purely for reference from what I'm going to say. Now, these are actually, as I said, linear pots, and they're 50k total value. So if you put your test meter between the outside of the potentiometer, that's one channel and that's the other channel. When the knob is in the center, like this, you should read between the center and one lead 25k, and the same to the other. It won't be exactly 50k because the tolerance of these pots is about 10%. But what you want to do, once you've measured it and twiddle this accordingly, forget about this cutaway, that's irrelevant. Once you've found where the center is, you need to put the knob on here, exactly in the center, and mark it in some way, i.e. a line on the pot, something like that. So, and leave that knob on there. So once you've assembled it, which you can quite easily on the PCB with the knob already on it, you will know that at least electronically that is in the center, and it should give you a flat response. Boost and cut. So if you haven't got any test equipment to prove that you're getting a flat frequency response, that's the nearest way you can do it. And luckily, the fact these are linear pots, you should be able to do this. But I'll go through this later and show you whether what I've shown you works. I'm going to assemble this now and stop if I find any problems as usual. A couple of things to mention though before we start. It's nice to see that we've got 15 volt plus and minus supplies on this, which is very near the maximum voltage. I think it's about 18 volts is the maximum for these 5.5 series chips. Now what that means is it will have a very good overload capability, and you should be able to put in quite a bit of level before clipping. Clearly they're using one chip per channel, so with the pots in the center of travel, I would expect to get probably a gain of about 6, which is what you typically get from one, well, in these typical circuits. Now obviously you will get more gain as you turn that particular frequency up. This is one reason why you need to run this at the higher voltage level. More about this later, but basically all I'm saying to you is on paper they seem to be doing the right things. It's got these little orange drop capacitors in the EQ circuits and no-name brand electrolytics of dubious quality. Resistors are all the typical ones you find in these kits. Generally pretty accurate, and they tend to have a 1% tolerance again, which is really what you need for any EQ circuitry. I'm about halfway through assembling, and I thought I'd break here to show you this capacitor is a 4.7 microfarad, and there are no identification marks on it regard which one is positive and negative, but the short lead is in fact a negative. That's generally the rule on capacitors, but in case you don't know, and say if you're looking it up, the short lead is negative. I finished assembly, and I have to say it all went together pretty well really. I've still got to inspect it yet to make sure I haven't made the usual solder bridges and things to stop it working, but I'm going to do that now, and if it all looks well, I'm relatively confident to apply power. Now this needs AC input, and as the regulators are 15 volt regulators, I would suggest you might get away with a 12-0-12 transformer, but probably a 15-0-15 would be better. Now it's going to consume a few milliamps, so there's no issue here with these regulators not being on heat sinks. In fact, I doubt they will get even warm to touch. Now here's my quick Lash Up test, and here's my 15-0-15 transformer, which is going off to the mains. The input is from here, and that's coming from my computer sound card, and the output is going to come from here, unfortunately via this cheap and nasty, horrible Chinese rip-off plugs. And I say that because there's no screen on here. The earth is just another conductor, so I'm expecting a little bit of a buzz but it's the only lead I've got at the moment that's open end to dubious phono plugs. This will go into my monitor amplifier, which you've seen me use dozens of times, and then we'll just switch it on, play some music through it, and test the various controls and see if it basically works. This, I'm going to show you the current draw. Now, I'm measuring this from the AC side because obviously AC goes into it, and to break the somewhere in the PCB to measure the current won't be easy, but basically you need to know what transformer to use. So I'm going to put the power on now, and you can see it starts at about 50 milliamps and settles down once the capacitors have charged to just over 9 milliamps. That's per rail. So literally you could use the smallest transformer you could find on the planet. 10 milliamps AC is the requirement from the transformer. I've got a piece of music on here which I'm just going to show you briefly the range of the tone controls. Now, I did mention that I thought the potentiometer on here will be a bit cramped at one end, and it is. It all happens there, and then from then onwards there's virtually nothing extra in gain past halfway, so that should be a log pot, and it's just they don't care when they put these kits together. All the tone controls work, but I would say that the gain of the preamp, I said it at the beginning, I thought it would be around about 6, but with the tone controls flat, there is virtually no gain at all. Treble, mid, and bass. And volume. Needless to say, it doesn't have any noticeable noise because it doesn't have any noticeable gain. All the gain, if you was to put all 3 tone controls on full, you would be gaining about 15 dB of gain, and that's why the actual preamp itself doesn't appear to have any gain, because if you had a circuit, these so-called passive tone controls, they have an insertion loss of between 6 and 15 dB, because if you think about it, you can't get more out of a passive tone control network than you put in. It's not possible. So they always have an attenuation. So this is basically what this is. It's a preamp that makes up for the fact you've got tone controls. And in fact, when you've got the tone controls on minus, you're actually getting less out than you're putting in. So it's an attenuator. So to recap, with the tone controls on on full cut, it's probably about a 10 dB attenuator. With the tone controls flat, there's probably a minimal amount of gain, but I haven't measured this yet. But obviously with the tone controls on boost, you're getting probably between 10 and 15 dB lift. Obviously the transformer comes in here. There is just there, under my finger, a bridge rectifier, and these are the main smoothing capacitors. You've got the regulators, and all round them are these low value capacitors, which are across each of these are the capacitors which are after the regulators. So you've not only got a supplemental smoothing, always a lower value after the regulators, because the main smoothing is done here. All these capacitors here, those 4 are across the bridge, which again is very good for noise rejection, and these capacitors here are after and before the regulator, with the main electrolytics being the smoothers. These capacitors here are the capacitors that govern the turnover frequency of the particular EQ board, part of the board. I've adjusted the knobs on the tone controls to give the best possible square wave at 1 kilohertz. Ignore this one because that's the volume, and obviously that will be wherever the volume is. But the tone controls are fairly accurate. I was surprised. Now that's the best square wave I can get. If I'm adjusting the treble control now, and you can see the smallest turn changes how the square wave looks. And I've adjusted it now. This is the mid-range. You can see what it's doing to the square wave. And this is the bass. Again, ignore the squiggles on the waveform. That's my cheap scope. So if I adjust that now, that's the best I can do with the tone controls. If I do a frequency sweep, that should be pretty flat, but you can see the rise time on the scope is quite slow. And this is what I've mentioned to you earlier, why I don't like tone controls, because I'm adjusting this now by barely movable. I'm barely moving the knob on there, and you can see how critical it is. And the actual shape of the square wave will show you that, bearing in mind that's 1 kilohertz, that should be pretty well perfect square wave. But you can see the rise time. If I change the time base a bit, you can see that it's not exactly 20 minutes, but it's quite slow. And this is what introduces colour to the sound, because if it hasn't got that attack, that's what tends to make it, if you would call it, muddy and lacking in detail. We know that this chip gives a pretty impressive square wave. So it's not the chip, it's the associated circuitry and the phase shift that you get when you put tone controls in, and why I generally don't like them. If you look at the meter here, the 0 dB range, I've adjusted 1 kilohertz for 0 dB, and I'm turning the frequencies up now, and we are now at 15 kilohertz, and we're half a dB down. Now I can correct this slightly by adjusting the treble control, but it will take away the flatness overall. And in fact, I'm going to do that now. I'm going to turn the treble control up so we're at 0 dB and continue going up in frequency. And see, already that's now 1 dB down again, but we're at 22 kilohertz. Now I can continue to use the treble control and bring that up, but the treble control is now at 1 o'clock, and you'll find if I now go down in frequency, the frequency level goes up. So you can see we've lost the flat characteristic. This is why so many tone controls call it plus and minus 3 dB, rather, because if you think about it, an amplifier should be flat as a pancake until it starts to roll. It shouldn't go up at all. We're at 100 Hertz now, and we're flat, as you can see. Well, it's still flat at 20 Hertz, which is pretty good with the tone control on center. Now look what happens when I adjust it from minimum to maximum. That's 22 dB of gain at 20 Hertz, which is insane. If you've got a turntable or something like that, that would emphasize the rumble chronically. I mean, to give that amount of lift at 20 Hertz is just ludicrous. Well, I've done all the tests I'm going to do. What's my verdict? Now, great fun to build. All the parts went together perfectly without any problems at all. The preamp does colour the sound quite a bit. And the main reason is that the controls are so critical, whether they're just that fraction off centre changes the balance of the sound dramatically. And I think the range of the board is way too high. Let me tell you what I mean. In some of the better amplifiers that do incorporate tone controls, the range is quite limited, and it's quite common to have plus and minus 6 dB on your tone controls. And you think, well, that's not very much. But their argument is, if you've got a high quality amplifier and good speakers, why do you need all this range of tone controls, which increases distortion, increases phase shift? And that's another reason why the amplifier seems to add, or the preamp I should say, seems to add colour to the sound, because you're changing the balance. And even with the control central, you do get a degree of phase shift, which tends to, the effect on the ears is that it's muddled. You don't have the defined positioning. So this is one reason why I tend not to favour preamps with tone controls, because it shouldn't really be necessary. If you do need to adjust the balance, then there's something potentially wrong with your system. I know we all don't live in perfect houses, and the acoustics in one may be echoey or bass heavy, and then it's debatable that you need to have tone controls. But bear in mind, I've not found a circuit yet that changes the tonal balance without affecting the sound. Even in the digital ones you find on the computers, they do make the sound less detailed. And that's what hi-fi is about, isn't it? It's about detail. What about the kit? Great value for money. I mean, it's under 10 New Zealand dollars, including postage, tax, and all the other horrible things that happened when you buy something. If you're building something that's not of that importance, and you just want it to be able to change the bass and treble and mid-range for that matter, you could say it's a good addition. And I'm tempted to use it here with my monitoring system for my computer. But certainly in a hi-fi environment, you'll be disappointed. But saying that, $10 is not a lot of money. So if you want to try it for yourself, just go and buy the kit. You'll enjoy making it for sure. And if you like the sound it makes, fine. But I'd be surprised if you'd find it adds something. Now, I know I've mentioned this before, but if you add something to your system, i.e. more bass, more treble, or take the mid-range down or something, initially you think, that sounds better. But you can't make a good signal better. You can change it. You can't make it better by adding tone controls. I've mentioned this so many times, but I keep getting asked the same question about these circuits. Does it make it sound better? No, it doesn't. It can't. All it can do is change the balance of the sound. And if you're the sort of person that likes huge amounts of bass, then this will give it to you. I mean, insane amounts of bass, ridiculous amounts of bass, because the tone controls have a range of plus and minus 15 to 20 dB, which is ridiculous. I might experiment with this yet and see if I can reduce the range to a maximum of about 7 or 8 dB, and then it can be arguably better. But as it stands, great value, you'll enjoy building it. Thanks for watching.